Hello, my geometry geniuses. Mr. Stewart here. Sorry, I was having issues. My mask got stuck in my headphones. Okay, so today we're going to divide segments proportionally and use some of the steps that we did for finding the original location of our robot from one of our earlier lessons to do that. Some of this is going to be done on a graph, some of this not on a graph. So let's start off with some basics. On a number line, I want you to draw point A at -7, draw point B at 5, and if we wanted to put C exactly halfway between A and B, that means point C would be at -1. So one of the things that we're going to have to do while proportioning our segments is work with ratios. So ratio is just a comparison of lengths. So when they say the ratio of AC to CB, that means they want the distance from point A to point C as the first number in your ratio, and the distance from point C to point B as the second number in your ratio. So technically what we have here from A to C, 1, 2, 3, 4, 5, 6, would be 6 units. 6 numbers on our number line. So to start with, our ratio AC is 6. And then from C to B, 1, 2, 3, 4, 5, 6 again. So when you write a ratio, remember that you can write it with a colon, 6 to 6, or write it as a fraction, 6/6. Now when you write it as a fraction, that's the easier way to see how it reduces to 1/1. If you were asked to do this as a scale factor or write the ratio in fraction form, you just have a 1, as it's given here and what we'll need to interpret later on in the unit. From AC to CB, our ratio is 1/1. If you put 6 to 6, that would also be okay because those are the accurate lengths. All right, so let's look at some other ways to do this. Find point D, the point that is exactly 1/4 of the way from P to Q. What is the ratio of PD to PQ? We are going to put point P at -9. We're going to put point, what else do we need? Q up here at +7. Now I want you to find the point D that is 1/4 of the way from P to Q. 1/4 of that distance means to count the distance from P to Q and divide it by 4. So we know where to put the location for D. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So from P to Q is 16 places divided by 4, which means we will put point D 4 spots from P towards Q. From P to Q. So from P, 1, 2, 3, 4 spaces over, that is where D is located. So that gives me the location of D. Now let's answer the question. The ratio of P to D, from P to D, 1, 2, 3, 4, to P to Q. So from P all the way to Q, which we know is 16. And we know that because we already counted it over here. PQ is 16. That reduces down to 1/4. So I could put 4 to 16, or the simplified version, 1 to 4. Notice that in the first question, we wrote our ratio from A to C and then C to B, but the second one, we did P to D and then back to P all the way to Q. So these ratios are going to change. It's not the same thing every time, but you just have to be careful and know what points you're using. It's not a difficult thing. You just have to pay attention to what's happening. Okay, so for letter C, find point E that is exactly 1/3 of the way from R to S. What is the ratio of RS to ES? So we're looking for point E. Point R is going to be at -4. So that'll be R. And then point S we'll put up here at +8. And we want to find point E that is exactly 1/3 of the way from R to S. So what I did last time is I counted spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Mathematically, if I didn't have a picture, because that's eventually what's going to happen, is I'm not going to have a picture here to do this, I would do the coordinate for point S minus the coordinate for point R and realize that they are 12 spaces apart. Then to figure out the point that is exactly 1/3 of that distance, I would do 1/3 of the distance between them so that I know 1/3 of the way would be 4 spaces. And then I would take the position point for R and add 4 spaces to know where the position point is from point E. Now on a graph, we could count, but we're not always going to have a graph. But now that we know where point E is, now we can answer the question for the ratio. Ratio of RS, which we already counted was 12, to ES, 1, 2, 3, 4, 5, 6, 7, 8. And then that ratio would reduce down reduced by 4, it would be 3/2. Okay, letter D. I'm telling you that we are trying to find H and K so that the ratio of HF to FK is equal to 2 to 5. What is the length of HK? So I'm going to give you point F, and I'm going to give you point F is at -2. You have to figure out the endpoints. So the ratio from H to F has to be 2, and the ratio from F to K has to be 5. So the easiest way to do this is just take our point and move it 2 spaces away from F, and that'll be the correct location for H. And then I could take the other point and move it 5 spaces from F to make that K. And it says, what is the length of HK? One, two, three, 4, 5, 6, 7. Now that is not the only correct answer, because I could have taken that ratio and doubled it and then moved point H 4 spots, 4 position points away. So move it another 2, and then I can move K an additional 5 away, and then the ratio would be 4 to 10, which would reduce down to 2 to 5, but then the distance from H to the new K would then be 14. And it wouldn't be a wrong answer, it'd just be a different answer that satisfies the same conditions. All right, and letter E. Find T and U such that the ratio of Tn to Tu is equal to 3 to 7. So we're going to put point N at -2. That will give us our starting point in the middle. So why don't you take a minute, pause, and find point T, find point U, and then write your ratio. So if T to N is going to be 3 units, and I just go 3 units away from N. And then if T to U is 7 units, I'm going to go from T all the way to U, 1, 2, 3, 4, 5, 6, 7. And then what's the ratio of T to N? 1, 2, 3. And then N to U, 1, 2, 3, 4. So I can either write it as 3 to 4 or 3/4. Okay, so now eventually what we're going to get into is doing exactly what we just did, only finding the points, maybe finding the point in the middle. We're going to do this without a graph. But let's first take a look at this. Plot the points, -6, 4. All right, there's point R. And then point S is 4, -2. It should be pretty easy. A person walking in a straight line from R towards S is at point R when time is 0, and is at point S when time is 2. Find the person's location after 1 second. Well, this is pretty easy compared to some of the ones we've done before. If they start at point R at time is 0, and then they're at point S at time is 2, then at time is 1 will be the midpoint. So you can either use your midpoint formula, or we can just tell from the graph, halfway there would be the point, -1, -1. -1, +1, I mean, -1, 1. So that would be the location after 1 second. Where would be the location after a half a second? So a half a second would be half of our half, halfway between R and our midpoint. So what we can do is use our midpoint formula again, just to make sure we have this an accurate calculation. So halfway between. There's our midpoint of our midpoint. So what we did, we found the 1/4 points, which is halfway from our starting position to the halfway position. So halfway from R to the midpoint. Now this was nice and easy because we're working with halves. So anytime we have to find the middle, we just do the midpoint. And then the middle again, we use the midpoint again. But obviously it's not always going to be that fun and easy. So what we're going to do is find the coordinates of point P that is 1/3 of the way from point M to point N, where point M is 6, 11, and point N is the point 0, -1, and we have no graph to do that. So I broke this down into the individual steps. So there's 3 things we have to do. First, calculate the horizontal and vertical directional change in distance. So very similar to when we were trying to find the starting position of the robot or the soccer player or the hockey player, depending on which practice question you refer back to. We're going to do the change in X, we're going to do the change in Y. So for our change in X, we're going to do X2 minus X1. And for our change in Y, we're going to do Y2 minus Y1. This tells me across the whole segment from M to N, the X values changed by -6 and the Y values changed by -12. So now I'm going to take those numbers and I'm going to multiply them by the scale factor, or our distance ratio. This is the partial horizontal distance from the starting point, and then it'll be the partial vertical distance from our starting point. So the scale factor goes back to the original question. We are asked to find the coordinates of point P that is bing, bing, bing. That's what we need. 1/3. So here's the visual. Quick little story time. 2 points. One labeled M, one labeled N. Connect them. Now these are 2 points on a graph. They're going to be somehow situated so they're not straight horizontal or vertical, but that's okay. Visually, I need to figure out where point P is located so that it is 1/3 from one end towards the other one. 1/3 from M towards n. That's how I know where it goes, because I read the words and I know what the words mean. From m towards n, 1/3 of the way. So that means my distance for x, which was -2, gets multiplied times my ratio of 1/3. I'm sorry, that was -6. And then for y, my distance of -12 gets also multiplied by 1/3, and that's -4. So these numbers are telling us that the horizontal distance, the partial distance from the horizontal starting point and the partial distance from the vertical starting point. That means that horizontally, our point P is -2 spots away from the original endpoint of point M. Because remember, we're measuring from point M towards point N. So this -2 is telling us that we have to go to the left 2 spaces on our graph to get from point M to get to point P. And then the 4 is telling us that we have to go down 4 spaces on our graph to get from point M to find point P. Now we're just going to do that algebraically. We're going to take the coordinates to go from M towards P. So our x coordinate for point M was a 6. And we are going to add our distance of -2 to that 6 to get an x coordinate of 4. And then we're going to do that same thing from point M again, because we're going from M 1/3 of the way towards N. So the coordinate, y coordinate for point M was 11. We're going to add in our -4 to show that we're going down 4 units. So that means that's at 7. What this is telling us is that our point P has the x coordinate of 4 and the y coordinate of 7. So we found the change in x, multiplied that times our scale factor, or the distance ratio, how far from one end to the other end are we going, and then we just applied how far it is from the endpoint, and that gives us our new coordinates. And then how can we verify that this point is actually on the line? Well, it says how can we do it. It didn't say we had to do it. How would we do it? We would write the equation. And then plug in point P. That's how we would know. So let's do it again. Find the coordinates of the point X that is 3/4 of the way from G towards H. We're going from G towards H. So from G towards H. Visually, here's G, here's H, there's G, there's H. I want to go 3/4 of the way, and that's X. All right, so first things first, x2 minus x1, that would be a 9 minus 3, so a horizontal change of 6. And for our y values, it would be -8 minus -3. I'm sorry, that's a 2. I thought something was a little off. -8 minus -2, giving us -8 plus 2, or -6. Second step, we are going to apply our scale factor to each of those numbers. So our scale factor was 3/4 of the distance. So I need to go 3/4 of the 6 units, which is 4.5 spaces. And then I have to go 3/4 of the -6 units for the y distance, which is -4.5 spaces. Now I just need to apply those distances to point G so I can figure out 3/4 of the way towards X. 6 is the distance horizontally from G to X. 3/4 of that distance is 4.5 spaces. So from point G, I'll go 3 plus the 4.5 units, which is an X coordinate of 7.5. And then from point G, our Y coordinate was -2. And I'm adding 4.5 boxes on my graph for 4.5 units. That would be -6.5. Because I'm adding the -4.5. Maybe I should write that a little neater for you. Let me do that a little neater and a little slower. I am taking the Y coordinate from point G, which is -2, and adding the distance 3/4. And I'm going too fast. Eraser, please. Thank you. I am adding 3/4 of that distance back onto point G, so I can go 3/4 of the distance from G towards H to figure out where X is. So 3/4 of that distance is -4.5. So -2 minus 4.5 is -6.5. That is our final resting point P. The X coordinate is 7.5 and the Y coordinate is -6.5. Now, order here does make a difference. From G towards X, I went 3/4 of the way. If I wanted to go from H and end up with the same coordinate, I would go backwards 1/4 of the distance from H towards G. So the order and the direction does make a difference as to our final answer. So let's look at example 3. Points R and S have coordinates R at -4, -2, and S at 8, 6. Find the coordinates of the point K such that RK is 1/5 of RS. So let's get a visual here. Here's R, here's S. We are 1/5 of the way. So that would be 1. And from R to S would be 5. So that means this piece would be 4 units left. Okay, so we're gonna first find our change in X, step 1, change in X and change in Y. So let's do that. Then we are going to apply our scale factor or the ratio. So we are going 1/5 of the distance. So we need to do 1/5 of 12 for our horizontal component. And we're going to do 1/5 of 8 for the vertical component. Then we're going to take those distances and apply to the correct endpoint. And that's why the sketch may help. So how do I know whether to go from R or from S? Well, if I go from S, I need to do 4 times the distance. If I go from R, I just know 1. So if we went from S, we would have used 4/5. But because we're going from R, we used 1/5. So I have to make sure that I apply this ratio to point R. So I take my -4 from point R, add the 2.4 from my calculations to get a X coordinate of -1.6. And then from R, I have X value of -2. I'm sorry, the Y coordinate of -2 plus the 1.6 equals -0.4. That is the coordinates for point K. negative 1.6, and negative 0.4. All right, that leaves us with one last problem to do. Technically two, but the last one's easy. Okay, so points J and V have coordinates. J is at negative 10, negative 8, and V is at 4, 4. Find the coordinates of point A such that the ratio of JA to AV is 1 to 3. So the ratio of JA to AV is 1 to 3. They did not give us a scale factor or a usable ratio here. Let me show you why. We are looking for point A. We don't know where point A is located. I have point J and I have point V, and those are the endpoints of our segments. And the ratio of J to A and A to V is 1 to 3. So A is somewhere here, closer to J than it is to V, because the ratio of JA is 1, like we did at the beginning of the lesson, 1 unit away. And then A to V, that part of the ratio is 3, so it's like 3 units away. So it was 1 part from J to A, 3 parts from A to V, which means from J to V would be considered 4 parts. That means our ratio that we're going to use, point A is actually 1/4 of the distance from J towards V. So we have to use a ratio of 1/4, not 1 to 3. This is why you have to be very careful of the segments that are being used in your calculation. But once we have that sorted out, the steps that we do are the same as what we were doing in the previous couple examples. 3 parts to our calculation. So let's get to it. Change in x, we do x2 minus x1. So that's 4 minus negative 10 gives us a horizontal change of 14. And then our vertical change, y2 minus y1, 4 minus negative 8, which becomes 4 plus 8, or 12. Now we're going to take those changes and apply our scale factor. So our scale factor, remember, was 1/4. 1/4 times 14 is 3.5. So we have to go 3.5 units from point J horizontally. And then vertically, 1/4 of 12 is just 3. So we have to go 3 units vertically. But we are going from point J towards point V. So our x coordinate for point J was negative 10. We're going to add in our distance of 3.5 units to get our x coordinate of negative 6.5. And then also, similarly, from J vertically, we go from the y coordinate negative 8 up 3 units to be at negative 5, giving us a final resting coordinate location for point A at negative 6.5 for our x coordinate and negative 5 for our y coordinate. Now for our last question, example 5, points A, B, and C have coordinates A at 3, 4, B at negative 1, 4, and C at negative 8, 4. Fill in the blanks below. Just make yourself a little sketchy sketch for this one. So point A, somewhere over here at 3, 4. Point B is at negative 1, 4. And then C is at negative 8, 4. Now, since they all have a y coordinate of 4, it's pretty easy to count to figure out the distances and to be able to write the ratios. So from A to B is 4 units. And from B to C is 7 units. So that means that B, this section here is 7 units. This section here is 4 units. So then B is 7/11ths. 7 out of 11 squares from point C towards point A. All right, from A towards, sorry, this would be C to A. We want A to C. My bad. So from A towards C, like I said before, direction matters. I have to read carefully. From A towards C, it would be 4/11. So you can see how if you're going too fast, it's very easy to get confused and use the wrong numbers. So take your time, do as I say, not as I do. Take your time, be careful, and be good to each other.